We're talking about intermolecular forces, and right now I'm going to describe to you the different types of intermolecular forces in a little bit more detail. The strongest type of intermolecular force, as we've already mentioned, is the ion-ion force. We've already covered this in the context of bonding when we first introduced different types of molecules and compounds, covalent versus ionic. And however, this ion-ion force is also described as the strongest type of intermolecular force because of the discrete nature of the ions. And the strength varies. All salts are not alike. The higher the charge on the ions, the stronger the attraction. So for example, in this case we have sodium chloride, but if we had calcium chloride, calcium has a +2 charge. Chloride, of course, still has the -1 charge. We would expect the attractive force between the calcium and the chloride, excuse me, and the various ions in that particular crystalline structure to be stronger. And then, for example, if you have magnesium oxide, magnesium carries a +2 charge, oxide carries a -2 charge, we would expect an even stronger attractive force. Okay, and we're going to look later in the next lecture about, are all ionic compounds soluble? And they're not, and we get to understand that based on the context of these intermolecular forces being different. In some cases, the attractive force is just too strong to overcome in a regular dissolving in water situation. So anyway, the strength varies. That's the point there. The higher the charge on the ions, the stronger the attraction. So ion-ion is the strongest type of intermolecular force, and even within that type, the strength of the ion-ion will vary depending on the charge and also the distance, how far apart those ions are from each other. Small, highly charged are going to be stronger than the low charged, bigger ones.